Hi students. So now in this session I am going to start some functions and their graphs. Clear? So in these functions definitely there will be one question for your annual exam or your terminal exam. Clear? Because it's a such type of very important question. Most of the time this type of questions has been asked in the previous exams. So on that basis we can guess that most probably there must be one question on the graphs by writing its domain, codomain and range. Clear? So my dear students, today in this session I am going to start some functions and their graphs. So we also call it them as special functions. Clear? So they are going to play very important role in the future concepts. So that's why I feel that if you understand or if you know the knowledge of this particular functions, it will be very helpful for you. So for that reason, my dear students, please concentrate more and more whenever you are watching the videos. Clear? Okay students, the first function is identity function. About this function you must know what all sets this particular identity function is going to be defined. And please remember, sometimes the domain and codomain can be changed according to the condition of the problem. Are you getting my point? Okay, so you must keep it in mind, but no problem. Here all the functions are going to be real valued functions. All the functions are going to be real valued functions. That means the domain and codomain are going to be the set of real numbers or the subset of real numbers. So if this condition is given for domain and codomain, we say that this particular function is real valued function. Clear? So now let us go through identity function. Okay, so my dear students, identity function means, already I have written the definition on board, but the logical thing of identity function means the value of the domain which you give as an input of the function must be the same output. That means, for example, if you give 1 as the input for the function, the same 1 has to be the output. Then we call it as an identity function, and it should be for every elements of the domain. It should be for every elements of the domain. That means, see here, let R be the set of real numbers, because this is a real valued function, so that's why they are mentioning let R be the set of real numbers on which this function is going to be defined as, see that, defined the real valued function f from R to R. Domain is also real number, codomain is also real number. So f from R to R by y equal to f of x, that is equal to x, for each x belongs to R, such a function is called identity function. So by reading these English terms in the mathematical textbook, you will not understand the logics straightforwardly. Clear? So that's why here the important thing is this term and f such that R to R. So these two things has to be decoded or has to be understood very carefully. Clear? So f from R to R means domain is also real number, codomain is also real number, and the function is defined as y equal to f of x equal to x. That means in the domain, this is the value of domain, that is R. Clear? So this x belongs to R. Are you clear? So which value you give as an input for this function, the same value has to be the output. Are you getting my point? For every, see this, for each x belongs to R means domain. Are you getting my point? So then we say that it's a identity function. If you get doubt, see here, If you understand this English or if you decode this English, no problem. If you don't understand, I will explain some terms here, you understand that. Okay. What I will do, I will take in a function f from R to R. I will take in a function f from R to R, and I will define a function on this relation f from R to R such that, see here, f of x equal to x for every x belongs to R, that is domain. That is domain. If you write this much also, you will get the full marks with graph. Are you getting my point? Say this. If you write this much also, you will get full marks with graph. But you have to mention this particular thing with graph. Okay. Graph I will draw and explain. No worries. But first you understand this. This is what written here. Are you getting my point? So f from R to R means domain, codomain. Both are real number set. Function is defined as f of x equal to x. Function is defined as f of x equal to x. This x is from domain and this x is from codomain. Are you clear? So the value which I have taken from this R will be the same value in the codomain. This both x are same. Clear? So if function satisfies this condition for every elements of domain, then we call this particular function as identity function. Then we call this particular function as identity function. Very, very important. Clear? So now if you want to draw the graph, see here, y-axis always called as codomain, x-axis always called as domain, and identity function graph will be the straight line passing through the origin. The straight line passing through the origin. Clear? So this much is enough. If I go on continuing, it is not in your textbook and it will be the outside of textbook, which is important for IIT JEE mains exams. There I will not cover now. Let us do it in the some other session of competitive exams. But here this much is enough. Clear? F is a function from R to R. Both R are real number sets defined as f of x equal to x for every x belongs to R, that is domain. And the graph is like this. Okay. So this is a real number set and this is also real number set. Domain is also real number set. Codomain is also real number set. Are you clear? So if you write this much, you will get the complete marks in your exam. If you write this, it is more than enough. Or if you write this much also, no problem. Clear? Because this particular thing is explained here. Okay. See, this R. Let R be the set of real numbers. They are explaining this. Okay. Next, define real valued function f from R to R. They are defining f from R to R. Okay. By y equal to f of x equal to x. That is f of x equal to x. For each x belongs to R. They are explaining this. Clear? Such a function is called identity function. The thing which is written here, they have explained in English grammar only. Okay. You can write, you can tell this like that also. Let R be the real valued function, let R be the set of real numbers. Define a function f from R to R, defined by f of x equal to x for every x belongs to R. Such a function is called identity function. Clear? So you remember these notations, you remember this graph. Next, the important thing is domain, codomain, and range. Clear? So, see, for every x belongs to R, that means from domain. So, domain is real number set. Here, codomain is also real number set. Domain is also real number set. Codomain is also real number set. And see the graph. Graph is also complete real number set. That means range is also real number set. That means domain, codomain, and range, all the three terms are real numbers. All the three sets are real numbers. So first thing, second thing, and the third thing. You have to write these 3 points. See, 1, 2 is the graph, 3 is domain, codomain, and range. You have to write these terms correctly. Okay. If you don't write these 3 terms correctly, definitely you are going to lose the marks. Are you getting my point? So this much is enough. I think you have understood about identity function. What is identity function? F from R to R, defined by f of x equal to x for every x belongs to R. That means what is the input, that has to be the output. Please understand that. If I put 1 here, output must be 1. If I put 2 here, output must be 2. If I put minus 1 by 3, output must be minus 1 by 3. That type of function is called identity function. So that we write it in the form of definition. F from R to R, f of x equal to x for every x belongs to R, that is domain. This is the graph, domain, codomain, range. All the 3 sets are real number set. All the 3 sets are real number set. Clear? Okay, let us go for the next function. Okay students, now let us go for the second function, that is constant function. Clear? First one was identity function and the second one is constant function. Constant function means, see here, f is a function from real numbers to real numbers. How the constant function is defined, I am going to explain. First with logical things, next let us write it in definition form. Okay, so f is a function from R to R. Here R is domain, here the next R is codomain. Both R are what? Real number set. This capital R is nothing but real number set. So f from R to R is defined as f of x equal to c. Is defined as f of x equal to c for every x belongs to R, that is domain. For every x belongs to R, that is domain, and c will be in the codomain. C will be in the codomain. That means, what is meaning of this particular function? If I give any values of domain, the output must be the same number, that is c. For example, if I take f of 1, output will be c. If I take f of 2, for that also output will be c. If I take f of 3, for that also output will be c. If I take f of minus 1 by 2, for that also output will be c. Clear? You give any real number as an input for this function, the output must be c. That is same number. It must not change. Clear? Output must be constant. If the output is constant, we say it is constant function. Clear? Previously, what was happening with this function? For every values of x, the same number was the output. If you put 1, output was 1. If you put 2, output was 2. If you put 3, output was 3. In the previous function, that is identity function. But here what happens? You give any value as input, the output remains the same number, that is c. It may be any real number from this codomain. Clear? That will be the fixed number. Output will be the fixed number. That means it's constant for every values of x belongs to R, that is domain. Clear? So this thing is called as what? This thing is called as constant function. This thing is called as constant function. Clear? So how will be the graph? See here. This is codomain, that is y, domain, that is x. So this is x-axis and this is y-axis. Clear? So from x-axis, if I give any values, the output must remain same, that is c. For example, if I put x equal to 1, for that also y is same c. If I put x equal to 10, for that also y is again same c. On the same side also like this. Okay. For every values of the x, the output remains same, that is c. This type of function is called as what? Constant function. See here, domain is R, that is real number set. Domain is R, that is real number set. Codomain is also real number set, but range is equal to singleton set C. Range is equal to singleton set C. Are you clear? Because from y-axis only one number you are going to get, that is C. You can't get any another number on the graph. You can plot this also. For example, you take see here, let it be f of x and let it be x. Clear? That means f of x is nothing but y. This x is from where? Domain. Are you getting my point? You take 1, you take 2, you take 3, you take -1, you take -2. Outputs remain as same, that is sum 5. Clear? So you try to plot this in the graph sheet or in a rough work, so that you are going to get this type of graph. Clear? For 1, 5, for 2, 5, for 3. See here. For 1, again the 5. For 2, the same 5. For 3, the same 5. For 6, for the same 5. For -3, the same 5. For -4, the same 5. Then you join all the points. Then you join all the points. The graph looks like this. Clear? So the domain will be R, codomain will be R, range will be the singleton set C for the constant function. Now you can write it in definition form also. Let f be the function defined from R to R, defined by f of x equal to C. For every x belongs to R, the graph for every x belongs to R, that type of function is called what? Such type of function is called identity function. You can write it in your own words. Don't copy from your any textbooks. You remember this. Looking at this, you define your own. Clear? Let f be the function from R to R, defined by f of x equal to C. For every x belongs to R, that is domain. Such type of function is called constant function, and the graph you may draw it. Clear? This is not needed. For your understanding, I have explained that is not needed. You just write domain, codomain and range. Are you clear? So if you write this much, it's more than enough for any exams if they ask what is constant function. Clear? Okay students. So in your textbook, the third function is polynomial function, the fourth function is rational function. But I will explain those two functions in the next class, because they are very important. If I explain now only, you will get a little bit confusions about it. So that's why let us put it in the next class. With the fresh mind, we shall go for those two things. So before that, we shall complete modulus function. Okay. So modulus function means it's again a positive function. That means your outputs will be always remain positive. Your inputs may be negative as well as positive. Then what it means, see here. Here what we defined, let f be a function from R to R. Let f be a function from R to R. That means domain is real number set, codomain is real number set. Are you clear? So from this, what we say, we define a function f of x equal to, we define a function f of x equal to in two ways. Very important. First one is x itself. That means what is input, that itself will be the output. For x is greater than or equal to 0. That means see here, if you take greater than or equal to 0 terms for this x, you have to choose output as the same number. Are you getting my point? Suppose if your x is lesser than 0, that means your input is lesser than 0, then your output will be negative of x. Clear? For example, see here. If I take f of 1 is greater than 0. If I take f of 1 is greater than 0. If 1 is greater than 0, where should I go? I go for this x. That means what is input, that will be the output. So that will be 1. Clear? So now if I take f of minus 1, see, minus 1 is lesser than 0. Minus 1 is lesser than 0. If I take f of minus 1 here, I go for this particular branch which is lesser than 0. What is your output? Minus of x. That means what is x term? Minus 1. So in the value of x, you write minus 1. The outside minus, write itself. So output will be what? If you calculate this, the output will be again 1. Are you getting my point? So inputs may be negative or positive, but the output will be the positive. The output will be the positive of same number. See, if I take f of 2, output will be 2, because f of 2 is greater than 0. I should choose this particular branch. So f of x will go for x. F of 2 will go for 2. If I take f of minus 2, minus 2 will go for the second branch because it is lesser than 0. Clear? So if I take f of minus 2 here, I should go for the second branch. I will write minus 2. Minus into minus will be plus 2. Again the output will be positive 2. Clear? So this is what your modulus function. So we write or we define it as f of x equal to x for x is greater than or equal to 0. F of x equal to minus x for x is lesser than or equal to 0, or we also write it as f of x equal to mod x. F of x equal to mod x, because most of the time it will be very lengthy to write, that's why we use this notation. But in exam you write this, that means you will practice this, then you will get a clear idea of mod function and why mod function is always positive. Clear? So that's why you practice this and you can write as or also this particular thing. Okay. So now what is domain, what is codomain, what is range? Before that, what is the graph? That is important. See here. The graph will be like this. We say it as the nature of graph. V-shaped straight lines and sharp edge at 0. Sharp edge at 0. You put 0 here. You will go for the first branch because 0 is included here. The output will be 0. F of 0, output will be 0. Clear? I think you got a clear idea of modulus function. Okay. Please remember the nature of graph. V shape. If you don't write the nature of graph, if they ask in exam, there will be no marks. Clear? Then what is domain? Domain is real number set. What is codomain? Real number set. Very important thing is range. So range will be what? Range will be, range is equal to positive real numbers. R plus means positive real numbers union with singleton set 0. Positive real numbers union with singleton set 0. Clear? We write union 0 because 0 doesn't have any positive or negative sign. Clear? That's why positive real numbers union 0 you can write. Clear? That is the range. That is the range of modulus function. Domain, no problem. Domain is real number set R. Codomain is again the real number set R. Domain is the real number set R. Either you write R or you can write it as real number set. Range is very important here. Range is what? Positive real numbers union singleton set 0. If you write this much, you can get the complete marks. And you can write it in definition form also. Let f be the function from R to R, where R is in a real number set defined by f of x equal to x whenever x is greater than or equal to 0, minus x whenever x is lesser than 0, or f of x equal to mod x is called modulus function. Clear? Then you can write domain real number set, codomain real number set, range R plus union singleton set 0, and this is the mod function graph where this is y-axis and this is x-axis. Clear? Okay, let us continue in next class.